Okay, so 6.6 I need the calculator for. So it's just basically solving exponential. So again, this is exponential form, and you can convert it to log form using this conversion. So if we start with something like this, okay, we can't solve it like that. But if we convert it to log form, it's going to be log base 2 of 5 equals x. And I have solved for x. Okay, and we can put that in the calculator a couple different ways I showed you last time. I'm going to use the change of base formula, which we can do natural log of 5 over natural log of 2, which is 2.322. Okay, that was a simple one. Now let's look at this. This one, the 8 is not part of the base. Okay, it's not part of the base, so we can't convert it to log form just yet because we need it to be a single exponential. But if we move it to the other side by dividing, that is now a single exponential. So if we convert that to log form, it's log base 3 of 5/8 equals x. Again, we can evaluate that using the change of base formula, or if you have one of the newer calculators, which probably most of y'all do, you can use the built-in change in the base. So that was base 3 of 5/8, or you could have done the change of base, natural log of 5/8 divided by natural log of 3. And it is approximately 0.428. Okay, now the last problem I'm going to work is really what is so useful with exponentials is solving these exponential equations that do not have the same base at all. Okay, now right now I cannot convert this to a log form, or I could, but it'd be like a convoluted mess. So we really need to do something to start with. But what the trick is we can take log of both sides. We know that if we have this, I can take log of both sides. Now, this is just log base b, so I can make it any log base I want. I'm going to use natural log because that is a function in the calculator. We don't need to do some crazy log base and then have a big mess trying to evaluate it. Just use one that's in the calculator, log base n or e, or just log base 10. I'm just going to use natural log. So if I start by taking the natural log of both sides, that's the place where you got to start. But I can use log properties to go ahead and solve this. Now, one of my log properties we talked about last time says anything that is an exponent I can write as a coefficient. So let's do that to both sides. Then from there, I can distribute the natural logs. So this is going to be x natural log of 5 minus 2 natural log of 5. This is going to be 3x natural log of 3 plus 2 natural log of 3. Now, look right here. This guy's just a number, this guy's just a number. The only thing that has an x in it is here and here. So I'm going to put those guys on the same side. But everything else was just a number, so let's put those on the same side. Okay, then to get x alone by itself, to isolate it, I can factor it out as a common factor. And everything in those parentheses is literally just a number. So I can divide by all of that. Everything in the parentheses. So now I have solved for x, and if I want to evaluate it, I can just go to the calculator. So I got to be careful how I put it in the calculator. I need to put parentheses around all of the top part and all of the bottom part. So that's going to be 2 natural log of 5, close the parentheses for that guy, plus 2 natural log of 3. Close the parentheses for the natural log, close the parentheses for the top. Now we're going to divide by the bottom, open parentheses, natural log of 5, close the parentheses for that natural log, minus 3 natural log of 3, close the parentheses for the natural log, and close the parentheses for the bottom. and we get it to be approximately negative 3.212. Okay, so that's a really good problem. Let's stop there.